Hello my friends, in today's episode I would like to share something about these three RF amplifier modules which are made by Mitsubishi Electronics. First, let's take a look at this module here, which type is M57741H. This module ends with the letter H, which means that the frequency range is in the higher end in the VHF amateur band. The input voltage is 17 volts and the input current is 7 amps. The maximum rating is this. And the input power, when the input power reaches 500 milliwatts, the output power can reach at least 35 watts among this band. This schematic shows exactly what this board is like. We can see that this board here has a very large thing which functions as a heat spreader, which can conduct the heat more evenly to the radiator. And we can see that all the components are mounted on a ceramic board, which is this one here. The white board here is a ceramic circuit board, which is very special. And the ceramic has very low loss under RF condition, which is quite important. But the ceramic board also increases the difficulties if you want to do some soldering on this board. So it is quite difficult to repair the whole board. But this one is functionable, so there's no need to do some soldering on this board. Just solder some wires onto the connections. Let's first take a look at the schematic. We can see here are two plus supply connectors, which are actually here and here. And another two connectors here and here are actually this input connector and this output connector. We can see there are three transistors, which are all NPN type RF transistors made by Mitsubishi itself. The final stage RF transistor, I guess you have already located it here, right? Under this silicon glue here. And the second stage RF transistor, which is this one, is actually under this silicon glue here. This one, right? Let me focus it better. What I just mentioned is this transistor, right under the screwdriver tip. This one, the larger one. And the first stage driver RF transistor is this tiny bit black spot here. This is the first stage transistor. This is the second stage transistor. And this is the final stage transistor. Okay? Now let's follow the signal path. First, the input signal passes through this DC bucking capacitor and passes through this L-type impedance matching network to the first stage transistor base. And this capacitor in series with this resistor here functions as a negative feedback, which will stabilize the transistor from self-oscillating, and also this feedback loop can enlarge the bandwidth. Okay, enlarge the bandwidth and increase the flatness over the whole bandwidth. And this is the bias, maybe not bias, but I just say it like this is a bias transistor, resistor, which bias the collector of the first stage driver. And also we can see that the first stage is a Class C amplifier, right? Because there are no bias voltage appear on the base of the transistor, but maybe not a traditional Class C because there isn't any inductor which will tie this node to ground. So there may be some leakage current from the collector to the base and to the emitter in this transistor. And this is a plus supply for both these two transistors. We can see the second stage transistor may functions under Class B mode, right? And it's a very simple single-ended amplifier circuit, so I will not do any explain on this one here. And this capacitor here connects the collector to ground, which functions as the impedance matching capacitor. And this one here is actually an impedance matching network, functions together with this capacitor, and also it will transform the impedance from the collector of the second stage driver to the base of the final stage. And this is a typical Class C amplifier because its base is connected to ground through these two inductors, which you can see are actually this inductor and this magnetic core. There is a wire goes through this magnetic core and in series with this air-cooled inductor. And this is the collector supply choke, also the filter capacitor, and the impedance matching network, and the output connector. There's an interesting design in this impedance matching network because the factory need to tune each of the amplifier modules specifically, so they designed this part of the circuit which you can see is this one. This capacitor can be moved along on this inductor, which functions as this parallel resonant tank. It can change the impedance on this path, so it can tune the output matching network for the specific transistor used on each module. So this is the first module, and this is the second module, which functions in the UHF emitter band, also the higher end among the UHF band. Also, this means the highest end of the UHF emitter band, right? The input power and the input and output power rating. And this is also a 3-stage amplifier module, but you can see the first, second, and the final stage are separated clearly, not like this one. The first and the second stage are actually glued together, and there is a metallized bonding wire which connects the this collector directly to the base of this transistor, which you may see. I'm not sure whether you can see it, but I will try. Okay. You can see there is a tiny metallized wire which connects this black dot directly to the base of the second stage transistor, right? This one you can see connects to here this metal plate and directly to the base of the second stage transistor. Right, these two metallized wires, very thin wires. Also, another thing I need to mention is that the resistors on the ceramic board is very special. They are these dark green traces. These are resistors, and I found that the Mitsubishi company had not found enough space for this resistor, so they just made 2 traces in series for making a larger resistor. The node hasn't been connected to anywhere except this capacitor here. Okay. So what I want to say, that this board here, this is another UHF amplifier, but it has been damaged. You can see the final stage transistor the glue has been washed off by using tetrachloric, I don't know how to say that in English, sorry, just C chloride 4. I don't know how to say that in English, sorry. But as you can see, the traces are quite different, and also there are some tuning spots here. Tuning spots located here. The capacitor can be moved up or down. This ground capacitor, which connects the ground to the inductor, and I believe this is a tuning spot, and also here this is another tuning spot for interstage matching adjustment, and no, there isn't anything I can see. Okay, and finally this module is for UHF TV cable television amplifying. The output power is 120 decibel microvolts. Not very large power, but maybe the similar power range as a walkie-talkie, or I don't know how to say that in English correctly, sorry. But these modules are quite cheap these days. I get these 3 modules totally for around just around $15 totally in total. So very cheap nowadays, but in the past, when these modules are just invented and launched into the market, they ranges from maybe $100 each, $80 to $100 each. And that's all about today's video, and thank you for watching.